My name is Omri. I had a research department at Gong, and today I want to talk about the lessons we learned building real-world machine learning projects and the difference between what we actually learn in data science classes. Great, so a bit about me. I had the research department at Gong. It's a group of 16 researchers, data scientists, but I also teach data science at Bar Ilan University in the hayaData program. And today is kind of like my confession about the differences between what I teach and what I actually do in practice. So I clean my conscience and then I can go back to teach very simple way things on how data science projects are managed. So a bit about Gong and what we do. I'll give examples from the different use cases. Gong unlocks reality for sales organizations, helping them have better conversations with the prospects. What does that actually mean, besides telling my mom that I unlock reality? If we have a 15 minutes phone conversation, and without Gong, it would just appear as something like that. With Gong, you can know who spoke when, what was actually said, the progression of the conversation, the topics, what happened in the video, okay? You can get alerts when competitors are mentioned. You can know if it's good or bad to talk about competition. What do top salespeople do? And how can you improve? We also analyze emails and all those interactions, and together with CRM updates, allow teams to have better conversations and understanding. And to use that, we have dozens of different models. Some are written here, and we'll give examples of a few in this talk. Across domains, we work on speech, NLP, predictive modeling, computer vision, and we actually see the same patterns happening across all domains. And these are the things that I want to focus on. So the textbook flow of machine learning models is we start with the data, getting the data, cleaning, preparing it, feature engineering. We train our model, we create a test set and evaluate our model on that, and then we improve and reiterate. What can go wrong? We usually have a matrix. Rows are the samples, the observations. Columns are the features. One of them is given to us as the target variable. This is what we need to model. Let's get to the best results we can on this data set. Now let's start with a simple project in Gong, LID, language identification. Okay, Gong provides transcription in 20 plus languages. They each have their own transcription engine, speech recognition engine, and we need to know the language of the audio call in order to send it to the correct transcription engine. Now, from like an algorithmic perspective, we do this on short audio segments. We do feature extraction using spectral analysis. We calculate the spectral coefficients. We have a TDNN architecture on top. We actually train the network to identify the speaker in each segment, and then we fine-tune that to the languages. But although those things are not really important. We're not here to talk about algorithms. I'll mention them here and there so you know that I'm just as geeky as you are. But today we want to focus about project management. So we start with very simple decisions, but they affect the way that we work. Is there really a language per call? Do we actually need to have like a data set of call ID and the language? What about having calls where I join with Tal, we both speak in Hebrew, and then somebody that doesn't speak Hebrew joins and we switch to English? How do we handle that? Does that mean we have to do a language identification per each monologue? Or what about like different people speaking different languages? When I grew up, my family used to talk Hebrew, except for the aunt from France that understood Hebrew but never spoke it, and my grandmother who spoke Tunisian, and once in a while people would mention a proverb in Arabic because proverbs sound better in Arabic. Do we actually account for that? What about English for the UK accent? People working on speech will tell you it's a different language. And people from Canada who speak French, Canadian French, can hardly understand people from France speaking French. How do we model these? So these are all decisions that we have to make. Okay, that's part of the data science project, as you all know. Another question we need to ask ourselves is what languages do we actually label? I mean, when we started at Gong, we sold in North America, and we had English and just a few other small languages. But it's kind of like waiting for, Columbus to discover America. And we're not even sure about how the world actually looks like. And many companies nowadays experience hypergrowth, so you don't really know how you model those things. And we talk about how you can work on those things and better build and understand your world as you progress. The obvious thing, okay, is that we cannot just split our data 80 and 20% or whatever, okay? We have to avoid leakage. In language identification, one source of leakage is if I have the same speaker in the train and test set. Even though if those are completely different conversations, that's leakage, okay? But we actually, when we work on those things, have two different dev sets, at least. One is when we have the split with different speakers to make sure that we don't overfit, to understand what our next step should be, but we also make sure that we have a set with completely different companies, which means that they probably use different recording systems and different bandwidth of the internet and different vocabulary and all of those things. Because when Gong and other companies grow as rapidly as they do these days, when we train our model today, most of the data it will see is completely different than what we trained it on. And we have to know how well we're doing it, and we have to prepare for all of the updates and changes. So we actually also have a test set for every model that we have with completely different data from a different distribution that is more like maybe the future for us. When we create a test set, we were taught that it should represent the real world for us, kind of like a miniature architecture. But let's think about the use case of speech recognition. So again, technically, speech recognition is either done with a network, end-to-end neural network, mapping audio directly to characters or words, or with breaking into acoustic models and a language model with much more complex algorithms. But the question is still the same. If Gong was built and created and trained and originally sold in North America, we have a great data of our own users speaking in US accents, Canadian accents, and that's great. We actually knew that our model doesn't really work very well in the UK, in Scotland, for example. But what does that mean? I mean, theoretically, if the world changes, okay, how do we actually account for that? What does that mean philosophically? What's the performance of our model? We have the same model, and we have a test set that we created, but 3 months into the future, our world is different. Is our model worse? How do we handle those things? So one of the things that we do is actually always evaluate our performance on the world and understand how that goes, but we actually have multiple test sets, not just one. We have a test set for Indian accents, an Israeli accent, UK accents, and all of those things. We know that the proportion of them in our data would change. Okay? But we know where we are on each of them, and we can also help with business decisions, understanding should we enter the UK or Europe? Do we need to work and invest in improving our models on that, or are we good enough? Okay, and so one of the things that we actually do in all of those projects is understand the subcategories and not just have one test set that's aimed to represent the real world, but accept change and build different test sets and always iterate and monitor our progress. Let's talk a bit about the differences between academia and the industry on other aspects. So in the academia, our criterion for success is getting state-of-the-art results on a data set, the best results possible. In the industry, I would define it as two things. One is to just be a good enough parent. You don't have to have the best model. You have to have something that's good enough, okay, and that provides value. And the other is that we don't embarrass ourselves. The classic example is this by Google. Everybody knows that, but I don't know how many actually spend a lot of time thinking about how you can really embarrass yourself in real-world scenarios. So let's talk a bit about how this translates into our world. We have speech recognition engine, and the metric for that is the word error rate, WER. Theoretically, it's kind of like the number of edits and changes we need to make into our own transcription to make it the truth, the ground truth label. We need to insert some words, delete some words, make some substitutions, and we have a metric for that, which is great. We try to optimize that. But at the same time, when we're working on a project, we have to make sure that we don't embarrass ourselves. And some of the things and ways we can embarrass ourselves are listed here. curses. People curse a lot in sales conversation. It's actually highly correlated with success in deals, in actually being able to sell. Now, Hanan was here. He's a big guy. He will hit me if I say that you should curse in order to win a deal. Obviously, that's not the case. It just means that we're feeling comfortable in a conversation, okay? But if we mistakenly transcribe something that somebody said as a curse when they didn't curse, that's a big no-no. That's a big problem. I mean, some companies make sure that their salespeople do not curse, never curse. It's just a matter of preference. And if we make such a mistake, that's a big, big problem. Redacted content. Some of our clients actually collect credit cards. And in Gong, we have a way to automatically do speech recognition, identify that a credit card or some private information was given, and redact that from the audio, actually removing this audio piece without any human having access to this system before to the content with the redacted content. And we can make tons of mistakes in our speech recognition, which would be fine. But if we got these numbers incorrectly, we transcribe the digit 2 as TOO, or 4 as FOR, the digit 4, and because of that, we didn't redact a credit card. That's a very big problem, like violation of the standards and things that we must avoid. Another thing is context. Okay, it's okay that we make transcription errors, but if we miss the name of the competitors, and we don't really know how to recognize them because it's not even a word in English, it's just some characters that somebody put and people try to guess how to pronounce, that's still a business problem. We have to make sure that we do very well on that. So like the average word error rate is useful, but it's not the only metric we can rely on, and we have to make sure that we have tons of test sets, small test sets. How well do we do on credit card numbers? How well do we do on the context and names of competitors? And we keep all of those in order to actually deliver a good model. Now, for us, it's really not embarrassing to not provide good quality in distant conversations, somebody talking very far away from the microphone, or with a lot of background noise, or crosstalk, because we hardly sell in Israel, we sell in the US, so people don't talk at the same time with others. It's weird the way they handle conversations over there. But these are like decisions that we understand. And for us, it's very different than for example, Google Home, Google Assistant, or Alexa. Totally different use case. And for us, these are things that we actually also have a test set for. We know that we are really bad at that. And it's a conscious decision because it's not our use case. It's not important to us. Another important thing that we want to make sure that our models do is know when they're making mistakes and know when they are unsure. It gives a lot of possibilities. So here you can see some examples from our image classification algorithm. It works on videos, extracts snapshots, and the goal is to say if what's actually going on in the conversation right now is a webcam shared, or a presentation, or browser, and all those things. We have a basic pre-trained ImageNet model, whatever, fine-tuned on our own use case. You can see that it's very confident about actual presentations that are very different in the fonts and colors and layouts and all of those things. And these are actually cases where it's not confident, okay? When we analyze those things, and a lot of time really plays with what Elior was mentioning earlier, this is because we haven't really properly defined the problem. Okay? Here we have a presentation inside a browser. But we had those as like a multi-class problem. So maybe we should actually treat this as a multi-label problem, which improves performance because the machine doesn't really know, what do you want me to say here? Because that's like a browser and a presentation. These are both okay. And when we make these mistakes, they actually are not really considered as mistakes. I mean, is this a presentation? Yeah, but I can understand why this might have been marked as a webcam. But that's okay, okay? And if we're not too sure, maybe we can abstain. We don't have to make a decision every time. Another algorithm is our Voiceprint model. Okay? We identify people according to their Voiceprint characteristics. The naive approach is to ask a person to record a few sentences and use that to build a Voiceprint model. We don't really do that. We do a smart trick. We don't even ask the person to label where she was talking in a conversation. Okay? We already have the conversation split into different speakers. Instead, we say something like this. And this is always something that you can add in the industry by flipping the problem. Okay? We can say, okay, let's take 5 conversations where Omri was supposed to take part in with different people. We'll try to create like a voice characteristic of a speaker in each of these 5 conversations. Let's say we have 10 speakers and do some clustering. And we can see that we have a cluster of speakers, okay, that appear in all of those conversations. And they're very far from all the other speakers. What does that mean? This speaker is probably Omri, because only Omri was supposed to be in all of these conversations. So it's not that we have a matrix, that we have a call and we are supposed to identify the person. With some thinking, you can just tilt the problem and make it much more cool, much more free, and much more easily done. This is a great algorithm. It actually reaches 99.9% accuracy or F1, micro F1. But that doesn't really mean that we get one call wrong in every 1,000 for the user. An average is misleading. This is the algorithm that people complain the most about in Gong. Okay, 99.9% accuracy, Voiceprint. The problem is that we have some users where we don't really provide good service for them. The algorithm doesn't really work well for them. And at least initially, the problem was that we didn't really communicate well the requirements of the algorithm. We need you to talk for like a minute or 2 in order to identify your Voiceprint. If you only spoke for like 10 seconds, it's not good enough. And we can't really use this information. The results don't really work well. But people still complain. Why wasn't I identified in this call? Okay, I already have 10 calls in the system. Why isn't it recognizing me? Okay, just making sure that you communicate what you're working on. When you say, and you have to say it, you set the limit at 2 minutes, okay, people understand. Okay, but if you just don't show a result or show bad results, people will complain. So it's also very important, besides just getting to the best results, to communicate why you gave a prediction or why you're not even giving a prediction and what people can do about that. Okay, so we have a model and we want to improve it. How do people improve performance? Hyperparameter optimization. There are many different smart methods for that. Bayesian optimization, NAS, evolutionary algorithms. In our experience, most of the time, it's just premature optimization. Hyperparameter optimization is great, but that's kind of like the last step in the process. What do you need to do instead? Work on data. When I teach students, if a genie grants you 3 wishes, what do you ask for? Data, data, and more data. And now we all know that we don't have to ask for 3 wishes. Elior told us we only need 1. Okay, 30% is enough. And then I say, okay, let's go and learn another smart machine learning algorithm. But honestly, if I can choose one thing to modify, the model or the data, I would modify the data. I would work on the data. Much better performance, much better improvements. And you need to understand that. Okay? What can we do? We saw some examples, finding more examples of the minority class, doing some active learning, understanding the space with embedding and clustering, even using external signals. We want to identify different accents and improving that. Let's take people whose names are Omri and Tal, and they probably speak in like Israeli accent, okay, or geography and stuff like that. And these things can help us get better and better, and from our experience, they really help a lot. Another thing that you can do and should do in the industry is cheat. Okay, for language identification, we can use more data, but even if we trained our model to predict the language of a single call, we also have a history. And we can use that, okay, to say, okay, we're not sure if this person speaks Danish or Finnish in this conversation, in this call, but from the history, we know how that goes. And when you are serving hundreds of thousands of people, like we do in Gong, okay, we even keep presets that a specific team that speaks Hindi most of the time and speaks in a certain language is mislabeled in production, and we have a rule for them to limit the number of languages that are available. Okay, and this can be a setting in the back, and that's fine. People would be happy to do that if this improves service. So a lot of times when you actually see how a model is delivered into production, tons of duct tape, tons of heuristics, okay? And it's not a place to be like a Puritan. And I saved you all a photo of how hot dogs are made in favor of this one. Another example, automatic transcription, speech recognition. When it outputs the transcript, it doesn't have punctuation marks. And we train it with a transformer network, BERT-like, okay, that was actually trained to predict the masked word, but we fine-tune it to give a prediction for each token about whether there should be a space, a comma, a question mark. At the top, we have a CRF. On top of that, this is the algorithm. We're not here to talk about algorithms. But we actually see that in many cases, the machine isn't really too sure if there needs to be a space, or a comma, or a period. Okay? And our solution for that was to use the ellipses, these 3 dots, which are kind of like in between. This was not in the training set. It didn't learn those. But just by making this change, we increase significantly the readability of the text. Okay, so you can, in many cases, do these kind of tricks and improve the perceived quality of your models, which is the important thing. Okay, when you're actually reaching production, one of my favorite quotes is machine learning models are like cars. The minute you bought the car from the dealer and you take it out of the driveway, it's worth 20% less. Okay, and account for that, be ready for that. When you actually see sunlight, when you have millions of hours every month, like in Gong, you're going to see tons of edge cases all the time. Okay, this is what you're going to work on for a long while when the model is out. And most of these can even be like engineering problems. Like you didn't design your algorithm to handle 300 people, which is the limit for the Zoom version, but you have calls with 300 participants. That happens once in every like 10,000 calls, but it does happen. And your algorithm can need to handle that. Or at least say, this call had too many participants and was not processed because of that. So what do? We actually keep a list of those edge cases. Every time the model fails, there's a big like problem, we keep that aside, and this is part of a test set for specific edge cases. We don't have to do really well on those, but we want to know that we are able to, most of the time, provide a prediction, and if not, communicate that and evaluate where we are. Some other examples. It's very important in production that you monitor your model. Okay? We actually monitored our model, this language identification model that we had in production, and we saw that in short calls, there was a high proportion of French. No real reason for that, what really happens. So we went and listened to those calls. Those are calls where people are actually calling on the phone to somebody, to like a company, getting the IVR, the routing system. Thank you for calling, ta-ta-ta. And when people are saying thank you for calling, there's background music. And now we have scientific proof that the most musical language of all is French, true story. And this really allows us to understand how we can improve the model. Okay? We just built a music detector, and when we are identifying the language, we don't use music segments. We remove them from the algorithm and make sure that the model is not trained on them. Problem solved. Another funny anecdote, just recently we improved our image classification model. What happens in a conversation, and we didn't have, and we had like a bug in production reported to us that people in Israel actually were in a conference room, several people sitting there, and it was misclassified as a presentation. So that's strange. We went to the training set, and we just actually saw that because most of it was collected during COVID time, in the training set we didn't have any conference room with many people. And the only thing that was in this training set that remotely resembled it was something like this, like a presentation with some text. I removed the text, and this sort of image. And this was labeled as a presentation, but the machine doesn't really know how that works. So if you're working on those things, you know how to improve that. But you can't anticipate all of those things in advance. So what do? You monitor, and you prepare yourself to constantly improve your model. And that's important, okay? Invest time to make sure that once you have a model out, it's not over. You have to go back and make some improvements or add heuristics and budget for that and prepare for that. Other important parts, anchor management. Let your user give you feedback. In our language identification model, we get good results, but there are tons of mistakes. 99% accuracy means that people still get a lot of wrongly identified languages. So we just give them the ability to go to the call and change the language. And that solves 90+% of complaints. Okay, they know what they have to do. We gather this feedback and we can train our model to improve that. Now we have more data. Now we know, that we actually have calls in Armenian. Let's add this and train our model on Armenian because we didn't even have that as a class before. Okay, we have a few more minutes. I want to talk about one specific, more challenging project, action items rephrasing. So we already have a detector for action items that does syntactic parsing of sentences, simplifying, saying, okay, this is the subject, object, verb, these are the word vectors, this is what we extract. Things like, I'll send it to you right after this is marked as an action item, and I can go back and understand this is what I want. But this is not really useful in and of itself. I have to go back and read the entire thing. So we want to generate something that is actually actionable and very concise, okay? But again, it's the same problem. We don't have a matrix. We don't have rows. We don't have a target variable. How do we actually work on a project like that? Okay? We need to choose our data. We also have tons of this is something that runs after a few other models. So we have transcription arrows, and our action items detector makes mistakes as well. And often it's really difficult for a person to understand what's going on. How do you balance all of those things? And our approach is finding an Oasis. Okay, and that's very useful in many of those very difficult algorithms. What this means is that yes, the world is very complex. Find the one place, the one group, whatever, that you think you're going to do well on, and expand that. Start with this, solve the problem for that, and then slowly expand. This means that if you're working on those things and there are cases where you need a very long context to understand what's happening, just decide that you're not going to solve these. Remove them from your training set, test set, whatever. You don't care about them. There's some part of the world, you might want to quantify them. It's not even a must, okay? You don't have to choose something that's the majority of the problems. It just needs to be a group that's interesting enough, and you can define it, okay? And you're looking to succeed and then revisit. And the one thing that you want to do is actually get customer feedback with this as soon as possible. Now, in many of these cases, when we're talking especially about text generation, you're always taught, find a metric, decide on a metric. Okay? You need to have a North Star. I don't think this is true. In many of those loonshots projects, those that might fail as a data scientist, except that there would be some obscurity, both rouge and blue and other metrics for text generation are just bad. I mean, if you try to optimize for them and eventually you find out that they're not really balancing what you really want. And so you're working very hard to optimize something that's not really what you should work on. So qualitative evaluation in the beginning is great. And what we actually want to do here is just talk to customers ASAP. Show them value, show them something. We can do this on these cases. Is that useful? How would you use that? What do you do with that? You show it to some customers. You actually integrate that into the product for some. Okay? But as soon as you get this feedback, the better. Just start with a strong baseline. I mean, succeeding in this is very, very difficult. But the one thing that you want to do is just take something that would probably be less than optimal, but can give you fast iterations. Okay? For our use case here, GPT-3 is a good example. Just start with it. It's not optimal, it's expensive, it's too big, you can improve that, you can do tons of other things with that. But if GPT-3 does well, and in many cases it does, you're off for a good start, and you learn how to improve your project all the time. the test set. How would you build a test set for a case like this? It's not related to like the distribution of the population or whatever. We actually have test sets for easy cases, hard cases, medium cases. And we know where we are benchmarked on these. And then we say, okay, what do we need to do to improve the medium cases or hard cases? And then we decide where we want to focus, okay? And when we balance them. But like an average metric across the world where there are some proportion is not useful for projects that are this complex. In many cases, when we have the data, okay, when we understand what we initially want to do, we use the Wizard of Oz approach. There is a model. Let us show you the predictions of our machine learning model. And we have people behind the scenes that actually sit down and write the predictions of the model. And we show that to customers. What do you say? We learn a lot, but many projects became much, much simpler because we really understood what users want and need and didn't really build what we thought they need. So that's very useful as well. I've mentioned GPT-3 as a good, a good platform for experimentation. The one thing that I liked a lot about that is just that you have a playground. And if you got a chance to do that and build something internally, if you can provide product people with like something to experiment with your model, some place where they can try examples and get feedback again, highly recommend that. It really helps iterations. And hopefully I was, able to show some of the differences and cases between teaching data science and actually doing it. It's a lot more fun to do it, but there are a lot of complexities. Very happy to connect. I'm around with office hours. If anybody wants during the break or later sessions, I'll be available. And thank you.